Have you ever stood by the ocean at night and wondered what lies beneath the dark, churning waves? Our universe is a vast, cosmic ocean. For centuries we've been standing on the shore, gazing out. The darkest, deepest parts of this ocean hold secrets we can't even imagine. This cosmic curiosity drives us to build bigger telescopes, to sail further into the unknown. The darkness beyond Neptune has always been a source of fascination and mystery. We called it Planet 9, a giant playing gravitational hide-and-seek. Now, new data is sending shockwaves through the scientific community. The cosmic ocean has just revealed one of its leviathans. So, what is this incredible machine that's rewriting our textbooks? Think of the James Webb Space Telescope, or JWST, as a cosmic time machine and a heat-seeking detective all rolled into one. Unlike its famous predecessor, the Hubble Space Telescope, which sees the universe mostly in the same kind of light our eyes do, Webb is designed to see in infrared. Infrared is essentially heat radiation. It allows Webb to see through massive clouds of cosmic dust and see light from the very first stars and galaxies. Its giant golden mirror, over 21 feet across, is a masterpiece of engineering. To do this, it has to be incredibly cold, colder than any freezer on Earth. This telescope isn't orbiting Earth like Hubble. It's a million miles away, in a special spot in space called a Lagrange point. Its mission is ambitious: to witness the birth of the first galaxies, to study how stars and planets form, and to look for the chemical signatures of life on planets orbiting other stars. While Webb was designed to look at the distant universe, its incredible sensitivity makes it a phenomenal tool for studying our own solar system too. And as we're now learning, it can peer into the dark, frozen frontier beyond Neptune and find giants that have been hiding in plain sight all along. To understand why this discovery is so groundbreaking, we have to take a trip to the edge of our solar system. Out past the rocky inner planets and the gas giants Jupiter and Saturn, you find the ice giants, Uranus and Neptune. Beyond Neptune lies a region called the Kuiper Belt. Think of it as a second, much larger asteroid belt, but instead of being made of rock, its objects are made of ice, methane, and ammonia. This is the home of dwarf planets like Pluto, Eris, and Makemake. For years, astronomers noticed something strange about the objects in the farthest reaches of the Kuiper Belt. Their orbits were weirdly clustered together, as if they were all being shepherded by the gravity of something massive and unseen. This led to the Planet 9 hypothesis, the idea that a giant planet was lurking in the darkness, its immense gravity shaping the architecture of the outer solar system. The darkness beyond Neptune isn't an ending, it's a new beginning. Finding a large, previously unknown planet in this region would be like finding a hidden room in the house you've lived in your whole life. It would force us to rethink the entire floor plan. The discovery didn't happen with a sudden eureka moment. It started as a faint anomaly, a ghost in the machine. A team of astronomers at NASA was using the James Webb Space Telescope for a planned survey of the Kuiper Belt. During a routine calibration, the telescope was pointed at a seemingly empty patch of sky to get a baseline reading of the background noise. But the reading wasn't empty. The sensitive instruments picked up a faint, persistent heat signature, an object that was far too warm to be a typical Kuiper Belt object. The team scheduled follow-up observations. Webb stared at the same spot again weeks later, and then again a month after that. The results were stunning. The faint dot of light had moved. This object was part of our solar system. It was orbiting our sun. Based on its faint brightness and its infrared signature, the object had to be enormous, significantly larger than Earth. Webb, with its unparalleled sensitivity to faint, cool objects, had finally unveiled the ghost that had been haunting the edges of our solar system for decades. Finding the dot was one thing, understanding it was another. The raw data from the James Webb Space Telescope is incredibly complex. This is where a new, powerful partner enters the story: artificial intelligence. NASA has been developing sophisticated AI algorithms, specifically designed to analyze the torrent of data coming from Webb. These AI programs are complex pattern recognition systems. We train them on vast datasets of known cosmic phenomena. The AI learns to identify what's normal. Then, we unleash it on the new data from Webb. The faint heat signature of the new object was exactly the kind of anomaly the AI was built to find. Once the object was confirmed, the AI's role shifted from discovery to analysis. The synergy between the human mind and the artificial one was crucial. This discovery wasn't just a victory for the telescope, it was a landmark moment for the partnership between human curiosity and artificial intelligence in the quest to explore the cosmos. So, the billion-dollar question is, what exactly did Webb find? The data points to an object of immense size, a true giant of the outer solar system. Current estimates place its mass somewhere between that of Earth and Neptune. This puts it squarely in a category of planet we don't have in our solar system, a super-Earth or a mini-Neptune. One leading theory is that this is, in fact, the long-sought Planet 9. It could be a primordial planet that formed with the other giants but was kicked out into a distant, eccentric orbit. Its discovery would solve the long-standing mystery of the weirdly clustered orbits in the Kuiper Belt. Another possibility is that this object is not a native of our solar system at all. It could be a rogue planet, a wanderer that was born in another star system and was later ejected into interstellar space. There's also the chance it's something entirely new, a class of object we haven't yet theorized. The universe is endlessly creative. The truth is, right now, we have more questions than answers. A discovery like this isn't just an interesting piece of trivia for astronomers, it fundamentally shakes the foundations of what we know about our place in the universe. For planetary science, it's a game changer. Our models of how solar systems form are based on the one we can study up close. Urbi nocer momum on. If there's a ninth massive planet hiding in the wings, our models are wrong. We would have to go back to the drawing board to figure out how a system could form with this giant distant member. This discovery reminds us that we might not even have a full inventory of the worlds in our own solar system. Could a giant planet this far from the sun have moons? Absolutely. And could one of those moons be warmed by the planet's gravitational pull? A process called tidal heating. Yes. This discovery also reignites the spirit of exploration. For a while it seemed like the big discoveries in our solar system were behind us. This proves that it's not. It tells us that there are still major secrets to be found right here in our own neighborhood. It inspires a new generation of scientists, engineers, and dreamers to look up and wonder what else is out there. Ultimately, this matters because it speaks to our identity as a species. We are pattern seekers. This discovery tells us to grab an eraser. The cosmos is not a closed book that we have finished reading. For generations, every child has learned the same basic map of our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. That map, etched into our collective consciousness, is now obsolete. The discovery of a massive object beyond Neptune isn't just adding a new dot to the chart. It's forcing us to fundamentally rethink the very structure and history of our planetary family. The first thing to be redrawn is the very definition of the edge of the solar system. We used to think of the Kuiper Belt as the final frontier. Now it seems it might just be the foyer to an even larger, darker, and more mysterious outer realm. This new object's orbit likely extends hundreds of times farther from the Sun than Earth's orbit. This vast, unexplored space, which we call the Oort cloud, has long been theorized to be the home of long-period comets. Now, we have evidence that it may also host planets. Our solar system just got a whole lot bigger. It forces us to think more deeply about how we classify the cosmos, pushing our language and our concepts to evolve along with our discoveries. So, what happens now? The discovery of this hidden giant is not an ending, it is the explosive opening scene of a new act in our cosmic drama. The immediate next step is confirmation and characterization. Astronomers around the world will be pointing every telescope they can at this object. But the Hubble Space Telescope will try to see it in visible light. Ground-based observatories will conduct long-term tracking to refine our understanding of its orbit. We want to know its size, its mass, its temperature, and what its atmosphere, if it has one, is made of. The long-term dream, of course, is to go there. It sounds like science fiction, but NASA is already designing conceptual missions to the outer solar system. This discovery should also fill us with a profound sense of optimism and wonder. In an age where it can feel like all the frontiers have been explored, this reminds us that the greatest discoveries may still lie ahead. The night sky is not just a static backdrop, it is a dynamic, evolving place. The universe just invited us to explore, and the journey is just beginning.